Welcome to Lesson 7 of Colgate VizLab's Lessons in Autodesk Maya, Basics of Domemaster3D. In this lesson, you will learn the basics of the Domemaster3D plugin, how to apply that plugin to your scenes in Maya, how to set up a Domemaster camera, and how to render a Domemaster image correctly. Let's get started. Domemaster3D is a pretty universal plugin from Maya that allows you to create, modify, and employ various conversions and cameras in order to produce content for the dome. You'll use this program here at Colgate University to produce content that will be put up on our planetarium dome, be added to shows that we produce, and be sent around to other groups once we produce them. As you can see up top here, Domemaster3D is its own plugin and its own tab. There are a number of different little tools here, and I intend to show you a couple of them today in our process. Most importantly today, up here, we're going to focus on the field of view, the resolution buttons, the reference grid, and the color material. Additionally, I'll show you the lat-long creation tool. Let's get started. Now, the most important thing that you're going to be using Domemaster3D for is the creation of dome cameras. When we produce a rendered image in Maya, we end up producing something that is excellent and well suited for a flat screen. However, as you guys probably have guessed, working here at the VizLab, you're producing content for the planetarium dome here and for other domes around the country. In doing so, you're going to need to be able to render an image that will fit that dome. When you initially render something in Maya, utilizing the Render Current Frame button here, you'll get something like this. This is a 960 by 540 image of the various objects I have spawned. The problem with this is when you attempt to take an image like this and paste it onto the dome, it's not going to fit. And in fact, no image that you produce here without the aid of a fisheye shader or the Domemaster tools will look correct on the dome, at least not in a way that would provide full coverage. So how do we fix this? Well, the first step is going to be to check your render settings. And make sure that Mental Ray is turned on. If for some reason you don't see Mental Ray, you can go under Plugins and find the maya2mr.mll. Load that, and click Auto Load so it loads next time. Refresh it, and close. Now, when you go to your render settings, you'll be able to find a Mental Ray tab. This will provide you with a host of different render settings, but the ones that we are focused on are the resolution presets. Working in the dome, and in particular working with dome cameras in the Domemaster software, we're going to need to use square images. This is because when an image is warped to suit a fisheye shader, like the type we'll be using in our Domemaster cameras, you're going to need an image that is a square and equidistant on every side. Basically, what happens is when the object, when the fisheye lens shader warps the image, it requires a square so that it can get a circle that is equilateral, equidistant from the center, etc. So Ideally, you want between a 1K and a 4K square. I usually use 1K squares for testing, or even 512 by 512 for testing. But you can also use 2K for that if you're looking for a little better quality. When we put stuff up on the dome, we use what's called a 4K square, which is 4096 by 4096, and it takes quite a long time to render. We use that for the final export of our production so that we can get quality enough that it doesn't look all grainy and gross on the dome. So now that we've had that established, let's move to a 1K square. I'll show you what that looks like. Now, as you can see, it's still an image meant for a screen, not for a dome. However, you do see that the resolution has been modified to suit what we need for the Domemaster cameras. This leads us into another point that I'll touch on briefly. If you want to adjust the resolution suited specifically for the Domemaster cameras, you don't need to enter your render settings, although it's helpful to know how. You don't need to go in here and change the presets under image size. All you need to do is adjust it here. So for example, let's say I want a 2K square, not a 1K. You just click to that checker box. You see it's rendering out. Now you can see here, it's now a 2K square, 2048 by 2048. Simple enough, right? Now, the next stage of the process, let's say this scene is done and you've set the base resolution and you're ready to create a dome camera for it. Well, what do? Well, your next step, let's say we just organize this in such a way that you'd want to show this off in a dome view, because not every shot is really suited to that. Get a few of these spheres up in the sky, a few objects sitting around, just to give you a good idea of what it looks like. Okay, so now that that's set up, our next and probably most important step is to create a camera. So, to create that camera, you're going to need to go up here and choose between FOV and LAT, or LAT. So, to create the actual dome camera, the one that we use the most of, we're going to use the field of view, or FOV, camera. And you can see down here, when I have it selected, it's dome AFL underscore FOV. That's the name that you're going to see in your outliner when we create this camera. So we can pull up our outliner, and there's our camera. Now, you can see immediately that we've created something that's slightly different from a traditional camera. What we've created here is a translatable, rotatable, non-scalable camera with a fisheye shader lens on it. What this means is that the image will now be warped to suit the dome. You'll also notice, perhaps, that the camera itself is pointing vertically. This is because when the Domemaster creates the field of view camera, the center of the camera image is now what's known as the top of the dome. It is the top apex of the dome. And you can even see here this little hemisphere that's been put on our camera is actually a representation of the dome. And so when you're looking through this camera, you can actually see what would be the center of the dome. And if we add our resolution gate here, you can just get a better view of that. So, basically, when you're setting up a camera to show off something for the dome, you're going to want to look at this guide and let it guide you, let it show you how to aim your camera. In traditional camera work in Maya, obviously you want to put your focal point here in the center and then, cluster the objects, basically try and get a good shot and that sort of thing. However, when you're working with dome cameras and you're working with stuff for the dome, your center ought to be somewhere around here. This ought to be the center of what you want to show. That's because if you attempt to put the center here, you're essentially making whatever's in the center directly up in the sky for your viewers. This is about where most of the viewership is going to be looking. That's because this is what's called front and center. This is like the front and the center of your dome when everyone's arranged in the theater in the Hotong Viz Lab. So we'll have this set up, and we'll make our focal point this cylinder here with a sphere up in the sky. Now when we click render, you can see that the image itself has actually been warped. Here being your ground plane, and the entire thing warped to a certain point. Now, it's a little hard to see with this black background here. However, let's go ahead and add, just for the sake of clarity, a giant sphere for us to sit inside. We'll reverse the normals on that sphere so that we can see it normally. So now we have this big white sphere and everything else. Maybe even add a color. Why not? Let's do a quick assign material. Make it blue. Why not? Blue's a nice color. And now, let's render that again. So now here, you can get a pretty good idea of what your dome camera actually renders. It's not actually the square that we've made. However, it is a circle that is inscribed in the center of this square, and it is a uniform circle. So basically, if you were to look at this image, this is going to be the top of the screen. This is a little ways down the screen. This is the bottom, front, and center of the screen. So in fact, I would need to tilt my camera further up to bring this down to the horizon line. This sort of thing would be completely behind the viewers. This is the center where the viewers, if they look directly up, would see, and these sort of wrap around to the sides. So that's sort of the rule book that you need to follow when you're setting up these cameras. So let's say I bring this camera back up a little, make this my center of the sky, and render it one more time. And now you can see that since this is the center of my sky, these along the ground plane are more balanced with the rim of this camera shot. That's pretty much the way you want it to be when you're rendering shots for the dome. This is the rulebook you want to follow. You know, your highlights, your up high places in the center, the stuff along the horizon line that you want to show in focus, and a variety of other things around the rim and up in the sky and things like that. So that's basically your bread and butter when you're working with Domemaster3D. You want to set up a field of view camera, utilize it and arrange it under the rules that I've taught you, set your resolution based on the way you want to do it, and render it out like that. Now, this camera is pretty much like every other camera in the other respects, in the sense that you can modify it like an other camera. Oh, I'm upside down. So you can, like other cameras, set keys on it and move it around. So, for example, You can rotate it, you can translate it. But otherwise, you, for the most part, don't want to touch the settings of the camera itself. You can change the focal length and things like that, and a clipping plane if necessary, things like that. But for the most part, you can leave it as is, unless instructed by Joe or another instructor. Now, there are three types of cameras here. Two of them are supremely important for us. We have the field of view, and we also have the lat long. Now, what a lat long camera does, if we create that, we'll just build us a camera that is meant to take wraparound barrel shots. Now, what that means is that, I don't know, for anyone who has a smartphone, have you ever taken a full horizontal panorama where you've started in one spot with your phone hanging up in front of your face and you just spin a full 360 and take images the whole way around? That is a lat long shot. It's meant to wrap around horizontally and then warp a little bit at the edges to be a full 360-degree dome. Well, not dome so much, but more of a sphere that covers you with holes in the top and bottom. This is used primarily for work with the Vive and the Oculus that you guys have. And it can allow you to create VR experiences, which I believe the VizLab will be getting into soon enough. So it's worth knowing how to create one of those. And it's also worth knowing that whenever you create a camera for VR or for a lat long, like if Joe says, create a lat long for me, like make this lat long, that means that you're not going to use the square, you're going to use a 2:1 ratio when you create your resolution. Now, unfortunately, there's no just quick snap button for that, but just understand that if you want to make a lat long of something, it has to be a 2:1. So if it is a 2K lat long, it is a 2, or it'll be a 4:2, so 4096 by 2048. If it is a 4K lat long, which we don't really use all that much because they're extremely heavy, it would be 8K by 4K. Or if you're testing, and this is the one that I find most commonly used, you're going to use 2048 by 1024, or if you're really pressed for quality, 512 in height and 1024 in width. Those are your options for cameras and resolution in your lat long setups. So once you're all set with that, you can feel free to render, and it will produce a slightly warped image, something like that. I'm tilted down a little bit here, I believe. Let's try and raise up a bit. See what that gives me. Or actually, I believe, yeah, okay, that'd be why. Not even in the right camera view, my mistake. Okay, so you got your lat long set up there. Let's see what this looks like. All right, so now you can see that it's sort of a smear. The blue with the shadows, that's just because the blue sphere is not lit all the way around inside. However, you do get the important part, which is to say you have the full 360-degree panorama, and you have the upper portions and the lower portions of it as well, which are smeared to fit this. Now, when you set this up as a full barrel shot or a lat long shot, you'll be able to take this frame and stick it on the Vive in our Vive viewer. I think they use Whirligig or one of the standard video players. But when you test this with the Vive or the Oculus, you'll be able to use this sort of image and get your wraparound shot that you can look around in. So there's that. And one more thing I'll touch on with Domemaster so that you're prepared, or I guess two more things. The first thing is this material here called color material. Now, the reason I bring this up is because, unfortunately, with a lot of using mental ray to render Domemaster shots using the field of view cameras, we run into a bug where it blurs out a strip a strip and a streak, in fact, of the image. For no discernible reason, it just does that. And occasionally it'll be on a specific object. And if you find that a specific object is having part of its texture blurred, you need to replace that object's material with this material here. Now, it's pretty simple to do. All you do is click on that and then click on the material, and it should bind itself there. Then you're going to go under Material Attributes, Color, Text, Image Name, and then grab whatever image you had for the texture for that object, and then just add it via that. Then you can go back to the material attributes and adjust them at will. It's a mental ray material, so it's pretty versatile. It has reflectivity and glossiness, and a variety of things. You can even adjust the index of refraction for specific materials. You have your color, which is just going to be your base texture, but is important nonetheless. The weight of that color versus darkness, all that sort of thing. So you just want to be able to use this material and the associated bump map if necessary, if your texture is bugging out when you're using Mental Ray to render field of view shots. So there's that. And one last thing I'd like to talk to you about is what's called the reference grid that you can create, as you see here, just to give you a basic idea of where you're placing things. Now, it's sort of, it's a little more comprehensive and a little more detailed, as you can see, than the just traditionally looking through the field of view camera. But it'll give you like a sort of framework as to like when you're modeling things or arranging things here, you can sort of see this is the dome, this is the full dome, this is the overhang dome for all full dome planetariums. You can scale it up and down, but it just creates that nice framework that allows you to sort of adjust your objects before starting to take shots out. So, yeah. Those are the tools that I figure you'll most likely need when you're working with Domemaster3D. If you have curiosity about the others, a guy named Andrew Hazelden makes Domemaster3D, and he has a webpage that you can ask Joe about. Additionally, I'm sure Joe could tell you just about anything you'd like to know about Domemaster3D. He is very well versed in it, so don't hesitate to ask him about further product and further tools within the product. So, yeah. This has been a Domemaster3D tutorial, and hopefully now you guys have a basic understanding of how to use that for your scenes. Thanks for watching.